I'm Melissa.
And I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Okay, are you ready for part 2 of helium?
I am very, very ready.
Okay, so this, I said it last time, but I'll say it again. This is a listener question. Esther R. asked, how does helium change your voice?
Mm-hmm.
Okay. The reason I wanted to separate the first helium episode and this helium episode was because before we can even talk about helium changes your voice, we have to talk about what your voice even is.
Right. Interesting.
Which is a pretty big question, right?
Mm-hmm.
Like, what is your voice?
You know something crazy that's happened since we recorded the first part about helium?
What?
I was watching an episode of Parks and Rec, and there's this one with my wife. There's this episode where they're throwing this prom for the school because they didn't have a budget to put on a prom. And Leslie Knope and this high school girl she's trying to mentor both like inhale helium and start talking in high-pitched voices. And then Ron Swanson walks up and says, "Stop wasting helium. That needs to be used in important things like welding and blah, blah, blah." And he lists a couple of things. And then she starts arguing with him, but her voice is still high. And so she's trying to argue back, but she's still talking really high pitch. But I was like, how crazy that just happened between the time that we recorded part 1 and part 2. That's nuts.
That is crazy. I don't think I even remembered that was a conversation they had on Parks and Rec.
Yeah. I mean, it's pretty quick, especially if you like weren't really, I mean, if you hadn't just recorded a podcast episode about it, it might not really jump out to you as much, but
right.
Because it's so not part of the main plot of that episode. But yeah, isn't that nuts?
But Ron Swanson knows what's up.
Yeah.
I didn't know it was used in welding. That wasn't one of the applications I found. So
that's the first one he says, I think. And he naturally is going to say things that are about like, making stuff or whatever. They're going to be higher priority for him. But
he's Ron Swanson.
Yeah. So anyway, I thought that was funny.
That is funny. Okay, so, but okay, that's a funny story. But can you answer the question about what is your voice?
I think Did
you just tell that story to deflect?
Mm-hmm.
So that you didn't have to answer the question, what is your voice?
And listeners at home, I think we can all agree that it worked.
It did work. It's like the age-old distract your teacher with a. Oh, before you tell us that, can we ask you a different question?
Yeah. Or it's like, oh, is that a photo of your dog, or just something like about their personal life?
Yeah.
Before they can give you any homework.
Exactly.
Okay, I think I have some ideas about what our voice is. I know it's vibrations in the air of some kind. Like it has a frequency, just like we've talked about other things, like any other kind of a wave. It has a frequency just like those do. But I'm trying to think like what it actually is, what has a wavelength, what has a frequency. Is it just like air pressure, or what could it be?
That's actually pretty close. So I relied heavily on an article from the Scientific American for this because all my textbooks were locked up in my office at the school until like a few hours ago. So, and I only rescued 2 chemistry textbooks, so this is more physics. So
Right.
The article described it as, and I thought that this was so easy to imagine.
Mm-hmm.
The article was in Scientific American. It was called, "Why Does Inhaling Helium Make Our Voice Sound Strange?"
Mm-hmm.
And I loved how they painted a picture in your mind. So the way any sound wave is produced is by the movement of something in a medium, like air. And in this article, they described the drum skin, so like the part of the drum that you hit. And imagine that. And when you hit that fabric, the tight fabric of the drum will move. And when it moves up, it compresses the molecules in the air around it. And then it goes back down and compresses on the other side, comes back up, compresses again. And so every time it compresses the air, it compresses the molecules in the air and it moves away. And as it does that over and over, the repetition of those vibrations in the air, making those little air compressions, is a sound wave.
Got it. Okay.
Does that make sense?
So the particles in the air are literally becoming compressed.
Yes.
Okay. Wow.
Isn't that cool?
Yeah. So you wouldn't say the word like, so what is each wave then? It's just air compressions. Is that what you say?
I think so. I think a sound wave is air compressions moving from where the compression started away. So you hit the drum and it vibrates, and with each vibration, it's compressing the air around it, and it moves up and away from the drum towards your ears.
Man, interesting.
How we hear it, I think, is a whole other thing.
Right.
I have friends in speech audiology who I'm sure would love to come on and teach us about the chemistry of hearing, but for now, we're just going to talk about the sound waves themselves.
Yeah, and even like the speaking part, like the vocal folds it's crazy that there's just this little part in our bodies that makes all these different sounds. And it's like so strange. Like there's a lot there that's super freaky.
Yes, I agree. It's really so strange. So what happens there with the drum head, the way the drum head, the skin on the drum moves back and forth and causes those compressions in the air, that's basically the same thing happening in your vocal cords. I think it's obviously, like you said, a lot more complex, but that's the general idea, is your vocal cords are making sound waves.
Right.
Okay. So you with me on that?
I'm totally with you.
Okay. Now here's the catch.
Okay.
These sound waves move differently in different mediums. So you talked about this with light, how when light hits water, the wave will move differently. Sound does the same thing in different types of air.
Would this be a good time to try my best to recollect like what other teachers have told me about this, or just let it happen?
I think you should recollect. Let's see if you got it.
Okay, so we didn't, I don't know when this was, so they would have not gone nearly as deep on any of these things as we normally would, probably. But the gist that I remember is that where you're about to go, I think, was the main part that I remember, is about our sound waves moving through different materials, and the difference of helium being a much lighter, having a much like lower mass, each helium atom, and that our sound waves can move like faster through it, which then seems like to our ears just makes it higher pitched.
Yes.
Even though it's not like the sound waves like changed inherently, they just move through a medium that they can move quicker through, kind of like the blue light on it from the sun.
Yes, that's exactly right. So what you said is perfect.
Dude.
Helium is less dense than normal air, so your sound waves move more quickly through helium than normal air.
Dude, that is crazy.
So I thought about a way to illustrate this is if you're trying to walk through like knee-deep water, how you move kind of slowly. But if you're walking through air, like normal on the ground, you can walk much more quickly.
Right.
That's the same way with the sound waves from your vocal cord through normal air. It's like almost like moving through water. There's some resistance maybe compared to helium. It's so much easier to move because it's less dense. It's almost like walking without any walking through water.
Yeah.
That's the picture that came to my mind.
That makes a lot of sense. It's like, it's just, oh, nice. This is so easy. Like it was, we were having to like work a little bit to get through the other stuff. And now it's just a breeze.
Yeah, that's what the picture brought to my mind. So you got it. I didn't even teach you anything.
I have to think like, man, I'm trying to remember what teacher that would have been, but I would have to guess my physics teacher, probably, right?
Probably so. This is definitely more physics-y than chemistry-y.
So my best guess is that was probably my old physics teacher in high school, Quinn Conley. So Quinn, wherever you are, I hope you're doing all right. Thanks for teaching me something, and I'm glad I remembered about probably 10% of the whole thing. So
probably even less.
Probably.
Oh, that's really exciting. Well, I'm glad that you got it, but I wanted to take a minute to be excited that it's kind of like helium doesn't actually change your voice at all.
Yeah.
I thought that was kind of crazy. It's like helium doesn't change your voice. It just changes the air around your voice.
Right. Which is like enough to make a huge difference, but it's not like, I think the way that we always think of it as kids is almost like, oh, I inhaled this thing and it's changing. It is changing my voice. It's changing. Like, I don't know what I used to think happened, honestly, but it seemed like it was something changing inside of my body almost,
Yeah. Like your vocal cords changed.
Right.
Is how it felt to me.
Yeah. So I kind of knew that one part there at the end, but the stuff at the beginning was definitely new to me. Do you want me to try to explain kind of a more whole picture of the helium changing our voice back to you now?
Yes, I think that would be a great idea. Yeah, go for it.
Okay, so like the drum, that's a really helpful visual. Like the drum.
Isn't it?
Yeah, especially because like I think we've all seen like slow-mo videos of drums or slow-mo videos of something like that where you really get to actually see the movement. Obviously, we know that's happening, but we actually seeing that really helps. And as it
thanks, Scientific American.
Yes. Thanks for being the scientific patriots that we need. So you hit the drum head and it moves up and down. So just like that, a sound, something that's making sound, is going to be both on one end, as like the drum head comes up, is going to be compressing the air above it, and then comes back down, and then comes back up again. So kind of over and over and over, super fast, is compressing the molecules of air.
Right.
Tighter together, and then letting off for a second, and then tighter together, and letting off for a second. And then that is moving through the air, which is kind of mind-blowing, I guess.
Yeah, I know.
Like these compressions that have been created are being sent out into the air. And
I know, it's crazy.
And something that's weird about air that doesn't feel that way to us is that it's more dense than other gases, especially helium. And so and partly because there's a lot of other things in the air, not just one type of element.
Right. There's nitrogen, there's oxygen, there's carbon dioxide, there's all kinds of stuff, all kinds of molecules in the air for sure. So when we talk about air, I mean, we're talking about the molecules in the air around us, which is a lot more than just helium, which is one pure gas kind of with a specific density.
Yeah. That is really weird. I forget that all the time. So it's more dense. Aren't all of those gases except for hydrogen more dense than helium?
I think the answer to that question is yes, because it's mass per volume. I'm not sure.
Well, I don't know those. I just was thinking about last week whenever you talked about helium, like floating up.
The atomic mass.
Yeah. Floating up above and escaping our atmosphere really easily. Something like that.
Yeah. So if you had like one single atom of helium, that'd be lighter than anything except hydrogen. Okay. Yes. Or any other element. But when we're talking about density and it's like how much of that gas is over a certain space, I don't really know.
Oh, it's not exactly the same thing. I get it. I see what you're saying.
Right. Yeah. So I can think of density as it applies to liquids very easily, but I'm having a little bit of a hard time thinking through how you measure the density of a gas. And I didn't look into any of that. So I think probably that's another question for another day.
And because it's less dense, when those sound waves, those compressions of molecules are moving through it, it's going to be more sluggish, has to fight a little bit more against that density in the air. But if you suddenly replace that with helium, it can move much more quickly, much less resistance. And so, and because all that we hear anyway, when it comes to sound, is those waves, they're moving much faster, then it'll sound higher to us. Your voice just sounds higher. It's not like your voice actually is higher. It's not like you're suddenly Santa's elf or something like that. It's just affected the way that your voice moves through space, right?
Right. That's exactly right.
Okay.
That was awesome. I'm so proud of you. You got to teach the listener something this week.
Hey-o.
Something science related.
It's so good, though, because, like, you know how it's pretty useless to remember just a tiny fragment of a little thing of a science thing and not be able to really explain why. You know what I mean?
Right.
And so it works great to have like, hey, I've got this little fragment, and then I can put it here in the context of this actual scientific information.
Yeah, I agree wholeheartedly. That was really fun. I enjoyed that you remembered that because, as a teacher, I teach my students and they leave and I think they're probably not going to remember anything that I taught them. And so it's fun to know that you left and did remember. You remembered something.
Well, we also did we didn't really go way into it about the molecules as much, but we did a project about like making our own speakers in that physics class in high school. And so that might be
that's cool.
part of why some of this is sticking a little bit better, because we did spend more time and effort on sound and sound waves and stuff like that than other topics, I guess. So there's probably who knows how much stuff that I don't remember, and I'll go ahead and apologize to Mr. Conley about that. But
well, either way, I think it's cool that you had a takeaway that you remembered and could bring here. So that's exciting. Okay, are you ready for 2 fun facts?
Yes, I'm very ready.
Okay, fun fact number 1. If you breathe in a gas that's more dense than air, it will make your voice deeper.
Whoa, like what gas could you even do that with? And how can we get some?
Okay, well, first of all, it's very dangerous.
Oh, okay. Yeah, totally.
Because it's more dense than air, so it can sit on the bottom of your lungs.
Oh.
Like, I think to actually get it out, you have to hold yourself upside down.
Oh my gosh. Yeah, that's a lot scarier than I expected.
Mm-hmm. Yeah, so it's dangerous. And a gas, though, that I think people use is argon. I remember them doing it on Mythbusters. That was the first time I ever learned about it. So, but I don't know what they use. But it is dangerous. Like I think you have to turn yourself upside down so that your lungs, like the gas goes to the bottom of your lungs when you're upside down, which has an escape. Mm-hmm. So it is pretty scary.
Yeah. Wow. That's very weird.
It is very weird. And then the other thing is apparently there's a trend where people we talked briefly about this last week, where people try to aerate their beer, like instead of using traditional carbonation, with helium. Mm-hmm. And then they claim that it makes your voice change, but it doesn't. Can you think of why it wouldn't make your voice change?
Could it be because you're not going to breathe the beer in? You're going to drink it?
Ding, 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 ding. That's exactly right. So they're usually, apparently the way it normally goes, people will be like, oh, I made this beer where I aerated it with helium and it changed my voice. And then the way the video stated it was, then internet nerds proved them wrong. But this was the American Chemical Society has a magazine called Chemistry and Engineering News. Mm-hmm. And 2 chemists, who also happen to brew their own beer, tried to aerate their beer with helium. And they said it actually is a lot like nitrogen, where the solubility is slightly less, I think. And so it has that creamier, like a nitro cold brew or a nitrogen aerated beer. But it's basically useless to waste helium on doing that for any extensive period of time, because you get the same results as a nitro cold brew or a nitro carbonated beer with just using a very expensive gas. So, but I thought that was fun that they did that experiment. So those were my 2 fun facts for you.
That's very interesting, man. And it's funny because we were just the other day, only a few episodes ago, talking about cold brew, and it's like, well, man, why would you use helium when you can just use nitrogen? Like, that's like crazy more available, right?
Yeah. Oh yeah, 100%. It's more available. So he said, he was the one that said he believes that the helium shortage is one of the foremost problems facing the scientific community. And he's like, for a fun experiment for a magazine, definitely worth it. For everyday use in getting your beer to be bubbly, not worth it at all. So I thought that was fun and interesting.
Dude, I saw this thing that was like somebody found a really easy way to make nitro cold brew at home. Like, they've kind of made a product that does a lot of the stuff for you. You just have to get some nitrogen or whatever. which is kind of nuts. I feel
Just get some nitrogen. That seems like it'd be harder than it sounds.
No. I mean, like, I think they probably sell it, but like, you have this little thing that does the actual hard part of somehow getting it into the cold brew. And so,
yeah, like to get it to dissolve is probably what's hard.
But it's kind of crazy to me that that's something that can be done at home now and not require like a lot of crazy equipment and stuff.
Yeah, it really is amazing the technology that we have in our homes now. Well, that's all I have for you on the chemistry front today. Did you want to share something about your week?
Yeah, I was trying to think I think a lot of our weeks are probably a little less eventful than normal.
Yeah, you know what's weird is normally, I mean, not always, but a lot of times you share stuff I've kind of heard about before, and I have no idea what's going on in your life. But also, is anything going on in any of our lives?
Right.
You know?
That's a great point.
It's just so weird.
And that's why I'm going to keep you guessing by not sharing anything. And I'm not going to tell you what's going on in my life. You can't know.
No, you have to.
This is kind of lame, but it was kind of a highlight of my week last week. You know how there's a lot of different tools and stuff for that people are trying to use and make and find and stuff like that to still get to hang out with your friends. So
yes,
we tried doing the watch a TV show on Netflix or whatever with friends on a video call, and your videos are all synced up, so you're all watching the same thing at the same time. So we did that last week, which was a little bit to figure out, but was definitely fun. And then we also did this was with some friends who already live like an hour-ish away, and so we don't see them very often anyway, but now we definitely can't see them. And so we did a thing where we played some games and used a video chat in order to do that, to all play the same game together. And so it's been kind of fun trying to do those things, and it was like such a fun night, which, in a normal season of life, it might seem kind of boring, like, just go, it's no comparison to hanging out together in person, but
oh yeah, definitely not.
In the situation we're in right now, it was a huge highlight of our week to get to see those people. We were on a probably 2-hour long video call, and at first we all just were eating our dinners and stuff, and then we started playing some games and stuff, and it was a lot of fun. But it's been kind of interesting trying to find new ways to connect to people, but also still stick to guidelines that keep us and others safe. So
yeah, I haven't really had much opportunity to try those. I've been actually pretty busy with family stuff going on, but now that my life is getting back to normal, I'm like, okay, what do we do for fun? What happens here? I don't know what I want to pick to share about my week. I could talk about how my roommate and I tried roller skating, and it's not the same as ice skating, in case you're wondering. But you know what? I think the highlight for me this week has probably been my Zoom calls with my students, and also actually my own class. It's just been, with my students, it's just been nice to hear from them again. It just feels like it's not the same. Again, like you said, no comparison, but it just feels like a little bit of normalcy. And then I attended my class this week, and I had listened but was not able to contribute to class last week. And the 2 weeks before, we didn't have it. And my professor emailed me and said, it was so great to hear your voice. And I was like, oh yeah, it's been a month.
Yeah.
It's been so long since we've all seen each other. And so I think just that feeling that it's almost the same as yours, but there's some ability to connect in the middle of this weird situation, and how good that feels and how important it is to have that community and connection has just been really good this week for me.
Yeah, for sure. Yeah, it makes a big difference. It's easy to feel even more alone or isolated or whatever, and so finding ways to keep connecting with people makes a huge difference.
Yeah, it really does. Okay, well, thanks so much for coming. I mean, you didn't come to my office, I guess. Thanks so much for walking into a closet in your bedroom so that you could learn about chemistry this week. I really appreciate it.
Anytime.
And thanks so much to the listeners also. We've just this has been such a fun experience, and it's really been interesting to see You guys stay consistent and stick around during all this quarantine stuff. So thanks for coming to learn about how helium doesn't really change your voice this week.
Yeah, thanks so much. Melissa and I have a lot of ideas for topics of chemistry and everyday life, but we want to hear from you. If you have questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share thoughts and ideas. If you enjoy this podcast, you can subscribe on your favorite podcast app. And if you really like it, you can write a review on Apple Podcasts. That helps us to be able to share chemistry with even more people. If you'd like to help us keep our show going and contribute to cover the costs of making it, go to ko-fi.com/chem4yourlife and donate the cost of a cup of coffee.
This episode of Chemistry for Your Life was created by Melissa Collini and Jerem Robinson. References for this episode can be found in our show notes or on our website. Jerem Robinson is our producer, and we'd like to give a special thanks to V. Garza and A. Hefner, who reviewed this episode.